Now in this video we'll study the analysis of RC circuit the moment switch is closed. In both charging and discharging case, we had a switch and we found out the various parameters when t is equal to 0 and t equals to infinity. Now in this video we will quickly summarize conceptually that during charging and discharging just what happens just after the closing of the circuit, just after the closing of the switch. So suppose if we have this circuit, we have an uncharged capacitor connected to a battery through resistor and the battery has potential V. Then as soon as the switch is closed, the capacitor starts charging. So this will be during charging. So when the switch is closed, we know that the charge that will appear will be equal to CV1 minus e to the power minus t by RC, and the current in the circuit will be given as V by R e to the power minus t by RC. This formula we have already studied. Now just after closing the circuit, that is at t equals to 0, it is almost at the same moment when the switch is closed, so t will be equal to 0. At this point the current, if t is equal to 0, it will be e to the power 0, so it will be 1, and I will be given as V by R. So this means that whatever current is flowing in the circuit, the potential will appear on R, and capacitor at t equals to 0 has no role. It will behave like a straight conducting wire, as if the capacitor is not even connected with the circuit and we just have resistor and the battery. So this implies that C behaves like a conductor as like a straight wire at t equals to 0, and at t equals to infinity, if we put t equals to infinity here, then this current will be equal to 0. The value will be equal to 0. That means there is no current flowing in the circuit because the capacitor is fully charged, and now it is not allowing any flow of charge from the battery. So we can say that at t equals to infinity, C behaves like an open circuit. As if the circuit is open, the wire is broken from between and there is no current flowing in the circuit. So this is the behavior of capacitor during charging at t equals to 0 and at t equals to infinity. Similarly, we can explain it during discharging also. So if this is capacitor and it is completely charged initially, connected to a resistor and a switch, and if we close the switch, then the capacitor will start discharging, and during discharging the value of charge at any time t is given as q e to the power minus t by RC, and the current during discharging in the circuit is given as q by RC e to the power minus t by RC. So at these points we can find out that as soon as the switch is closed at t equals to 0, that is just after closing the circuit, I becomes equal to q by c upon R, or it will be equal to V by R. This voltage is the same voltage which is being appeared on capacitor because of the charge. So this means that at t equals to 0, the capacitor is behaving like a battery. We also did this in the last video. So we'll write it here. C behaves like a battery because it is the only source of the flow of charge in the circuit at this moment of time. And similarly, we can find out at t equals to infinity, I becomes equal to 0. This implies that C behaves like an open circuit. That is, now at t equals to infinity, the capacitor is completely discharged and the capacitor is not able to supply any charge to conduct any current in the circuit, and it behaves like an open circuit as if the wire is broken from between and no current is flowing. So this is the analysis of RC circuit, a conceptual analysis just after closing the circuit in both charging and discharging. In both the cases, at t equals to infinity, the capacitor behaves like an open circuit, and during charging at t equals to 0, C behaves like a straight wire, it does not participate, and at t equals to 0 during discharging, C behaves like a battery.